The universe. As soon as this word is pronounced, our eyes already imagine a vast expanse of stars that beckon us. The universe is synonymous with grandeur, beauty, and infinite territory. Yet, it is difficult to accept this idea of immeasurable immensity in our logic based on the concrete, the reasonable, the visible, and the measurable. Only astronomy and the study of space allows us to define our place in this infinite world and to understand how ridiculously small we are on the scale of the universe. Dear traveler, good morning. Today, we're going on a journey to the infinite and beyond to discover the wonder of the cosmos. Before leaving for a new exciting adventure, think to like the video and to subscribe to the channel to not miss anything. Thank you all and have a nice trip. Since the dawn of time, the understanding of the universe has never ceased to occupy the minds of men. The human being, by essence, needs to understand his world, the environment which surrounds him, and the vast universe. The study of the stars is part of our history and our culture. Since the dawn of time, men have sought to answer their questions in the heavens. The universe is as magnetic as the core of the Earth's center. It dazzles, it intrigues, it fascinates. From a very young age, our eyes are attracted by the beauty of the sky. With our heads in the clouds and our minds in the stars, we dream of traveling through space and discovering its secrets. At the same time, how can we resist such beauty? It is undoubtedly the only phenomenon that the intense and deep night sublimates with 1,000 flashes. The colors, shapes, and grandeur of the stars that gravitate in the universe offer a magnificent spectacle. The stars dance above our heads to a tempo orchestrated by the universe. Raise your head to the sky and look. Isn't it beautiful? All those little points of light that seem to decorate the sky? This painting is Mother Nature's masterpiece. Both poetic and enigmatic, it reveals a little more of its beauty every day and lifts the veil on some of its mysteries. It took millennia of civilization to understand a tiny part of the universe that surrounds us. To define the universe is already a challenge in itself. It encompasses an infinite number of disciplines, and we're still moving forward blindly. Too many parameters are still unknown to us. Our knowledge on the scale of the universe is extremely limited, but we've made great progress in recent years in the field of technology. It's become one of our best allies in understanding space phenomena. Today, the definition of the universe is still a matter of debate amongst the greatest scientists of our century. Some refer to it as a notion of geometry and physics, others as an expanse. Abstract or not, others still as a container with an indeterminate edge. Whatever the case, it's home to an infinite number of astrophenomena, and we're going to discover each of them in an incredible journey. Are you ready to take in the sights and conquer space? You take the risk of feeling infinitely microscopic, a drop of water in the ocean, but you'll have the pleasure to discover an incredible place. Sometimes wonderful, almost fairy-like. It sometimes seems to be the closest synonym of hell. The space landscapes that you will discover and the amazing emotions that you will feel will remain forever engraved in your memory. These images will be imprinted in your mind, just as the impacts of asteroids have left craters visible from the Earth on the surface of the Moon. Man has been trying to understand the phenomena that surround him since his origins. It is the incessant questioning about life in the universe, about our place in this world, our critical spirit, or even our emotions and our system of thought that differentiates us from animals. If today even our youngest children know the basics of our solar system, the atmosphere, or the universe, there was a time when it was far from being the case. Great scientists such as Galileo or Copernicus suffered the thunderbolt of the church for having dared to think that the Earth was not at the center of our solar system. Before going any further, you must differentiate between space and the universe. The universe is a whole that includes the planets, the stars, the asteroids, and of course the Earth is part of it. Space defines the zone, the extent between two stars or two space bodies. In the past, at the beginning of the 20th century to be precise, it was thought that space, this expanse between planets, stars, asteroids, or galaxies, was simply filled with a single material, the ether. The ether was a fluid that we thought was capable of carrying the stars. The planets in motion, like a snake, relay on this liquid. It is unlikely that we could imagine such a vision of space, but don't forget that at that time, knowledge was limited, and the tools of measurement and observation were few and far between, and much less efficient than the James Webb Telescope. The nature of light and its transmission was not known. Today, we know that the space in the universe, that is to say, the space between the stars, is essentially made of vacuum. Well, not quite empty. This vacuum contains enormous quantities of gas, but also a few hundred molecules and atoms per cubic meter. We also know that light can propagate in a vacuum, and that the planets, by gravitation, can move without being supported by any matter. Without air to diffuse sunlight and produce a blue sky, space looks like a black blanket dotted with stars. If we have succeeded in defining space, we must now understand the basics of the universe. What is it? What is it made of? When does it begin? What are its limits? The universe is much larger and more complex than you might imagine. In its broadest definition, the universe includes everything we can touch, detect, smell, measure, or sense. These are the living things, the planets, the asteroids, the stars, the galaxies, but also light and time. Yes, it is difficult to accept this idea, but before the birth of the universe, there was nothing. No notion of time or space, no light, or even matter. In astrology, we call what happens above the sky the universe. If scientists cannot determine with accuracy the limit of the universe, it was necessary to mark its origin, its birth, its base. Why? For scientific reasons mainly, but also political. Indeed, if you use a flight device, such as a drone over a country, if you're in space, everything is fine. But if you're below, you are on their territory, and flights are therefore regulated. So we had to think about establishing a collective and international agreement on the subject. Finally, in science, a change always determines a new categorization. In the classification of species, for example, common criteria will make it possible to identify a class or a family, but divergent criteria generally lead to the establishment of a new class. For the universe, it's the same thing. Around and above us, there's the atmosphere. This layer that surrounds the Earth like a protective bubble is made up of gases, especially oxygen. It is therefore, among other things, the air that we breathe. The Earth is not the only planet to have an atmosphere. Mars, but also Venus, also have an atmosphere. However, they do not have the same properties and do not allow us to breathe as it is the case on Earth. This air bubble, besides its breathing faculty, also has a role of protection. It protects us from the sun's rays. Without them, we would literally be burnt out. Beyond the atmosphere, the properties are different, which is why a new name was necessary. Some of these changes can already be seen at high altitude when hiking in the mountains. The air feels different. If you are an outdoor recreationist, you must have already had that unpleasant feeling of bad breathing, as if you were lacking oxygen. The explanation is probably very simple. The higher you go, the less oxygen the air contains. No? Well, it's a little more complicated than that. The composition of the air is identical, about 21% oxygen and 78% nitrogen. What changes is the pressure. Near sea level, the pressure is strong. It therefore has an impact on the air, which it compresses, if we can put it that way. But the pressure is much less significant as we ascend. In other words, the oxygen or nitrogen particles are no longer compressed, but on the contrary, are much more volatile. In the same volume of air, there's therefore much less oxygen. The higher you climb, the stronger this phenomenon becomes. This is why you need to take many more breaths to get enough oxygen to supply your body with its precious benefits. Most of the air is found in the first 30 kilometers of altitude, or in the first 20 miles. There is no visible boundary or barrier to mark the passage between the atmosphere and space. By convention, it's estimated that space begins at about 100 kilometers altitude. Indeed, many parameters, notably pressure, air resistance, but also temperature, change from this point. Scientists have therefore defined this distance as the starting point. Beyond 100 kilometers or 60 miles above sea level, we enter space. And that's where we're going to go together to find out a little bit more about this extraordinary vastness. Here is one of your childhood dreams finally realized. You are in space. Extraordinary. This sensation of floating is extraordinary, isn't it? You're in the middle of the void, and at the same time, you're surrounded by billions of stars. The sensations are as incredible as the landscape is magnificent. You've probably already heard about the infinitely big and the infinitely small. On the scale of the universe, the Earth, as well as humanity, are part of the infinitely small. We are a tiny drop of water in the ocean. This may seem hard to believe and completely unimaginable, yet millions of billions of miles are over our heads right now. We are about to embark on an ascent into space. Do not take your eyes off the Earth. See how it is shrinking, little by little. From the size of a balloon, it becomes a tennis ball, and then a simple apple seed. See how tiny it looks in the middle of this immensity. Surprising, isn't it? It's quite something to get so far away from this little piece of Earth. The view is so impressive, it's almost hard to believe. Is it reality or fiction? I reassure you, you are indeed in space. You are traveling through the universe at the rhythm of the stars. The universe contains billions of galaxies. It is difficult not to feel small and insignificant in the middle of this vastness. Imagine that each of these galaxies also contains millions or billions of stars. There are more stars in the universe than grains of sand on Earth. Our galaxy is called the Milky Way. It is about 200,000 light years long. 1 light year is the distance light travels in 1 year, or 10,000 billion kilometers, or 6,200 billion miles. Such a great distance for only 1 light year, and our galaxy alone has no less than 200,000. If we imagine that man is capable of creating a device that is sufficiently solid and reliable to support all the phenomena and elements of the universe, and if we assume that he is also capable of conceiving a device that moves at 300,000 kilometers per second, or 186,000 miles per second, an astronomical speed that corresponds simply to the speed of light, it would take him more than 200,000 years to travel from one end of our galaxy to the other. This colossal amount of time would allow us to see only the Milky Way, our galaxy, but there are billions of others. You begin to understand how vast the universe is. We now know that billions of galaxies populate the universe. What we are still far from defining with precision is the size of the universe itself. It must be said that several phenomena and complex concepts make it particularly difficult to measure the universe. First of all, the universe is in perpetual motion, just like the bodies it contains. Then, the universe grows. It extends a little more each day. Finally, the distance is so great that in the current state of knowledge, it is impossible to express reliable and exact data. However, we can give an order of magnitude that's close enough to reality to have an idea of the extent of the universe. This data is beyond human comprehension. As soon as thousands of zeros follow each other, our brain bugs. Nevertheless, scientists and cosmologists have studied the question. They have relied on theoretical models, observational data, and complex calculation tools. They were then able to establish, to some extent, the size of a part of the universe. Scientists have broken down the universe into two distinct parts, if you will, the observable universe and the entire universe. The observable universe is detected by our measuring instruments. It is the visible part of the universe, the one that includes all the points of space-time sufficiently close to us to have transmitted their light to us. Beyond this limit, we can only extrapolate from data collected and knowledge established to make assumptions about the dimensions of the entire universe. To calculate the size of the observable universe, we must take into account the first particles of light scattered from the creation of the universe, that is to say, 13.8 billion years. Before that, they could not travel in space because it was not yet born. We can then measure the distance they could travel to propagate in our direction, but the calculation is more complex than it seems because we must also take into account the expansion of the universe. In other words, when these particles of light were traveling towards the Earth, they were also moving away from it as the universe grew. Do you understand why it's so difficult to establish exact data? Fortunately, our tools, the technological progress of this century, and the advanced knowledge of our astrologers have made it possible to establish a sufficiently realistic cosmological model. It is a sphere centered around the Earth, since we are basing ourselves on what we can observe from this point. Other data other than the emitted light completes this operation to calculate the distance of the universe. Temperature is also a data point that allows us to understand a number of phenomena in space. We know, for example, that when the universe was young, it was very hot. The wavelength of photons, they produce light, but these particles also react to electromagnetic interactions, has then undergone very little expansion. However, about 380,000 years after the Big Bang, photons are in a different wavelength, the microwave frequency of the electromagnetic spectrum. To estimate the size of the observable universe, scientists must rely on three major parameters: the expansion rate of the universe, its temperatures, and its composition. Matter, antimatter, or radiation can have a dominant impact on the results, and must therefore be taken into account when analyzing the data. According to the cosmic model established by the astrologers, the data collected, and the calculations made, the observable universe would have a radius of 45 billion light-years, or a diameter of about 90 billion light-years. This represents 900,000 billion kilometers, or more than 560,000 billion miles. Is at this moment that our brain does not have any more real understanding of the numbers. They exceed the human understanding. We are unable to realize visually a phenomenon of such great amplitude. As far as the universe as a whole is concerned, everything becomes more complicated because it's not observable. In other words, no measuring instrument or data collection can support our calculations. For some scientists, it could be 250 times larger than the observable universe. For others, it may well be 15 million times larger. The subject is still debated among the most recognized astrologers and cosmologists in the field. There are two main points of view within the international research team. Stephen Hawking and Jean-Pierre Luminet, physicists and cosmologists, think that the universe is finite, while Roger Penrose explores the thesis of an infinite universe. We've mentioned great names in astrology, physics, and mathematics. I think it's time, before continuing our journey into space, to evoke the first steps of man in this distant land. Since the dawn of time, man has been interested in the universe, but a political stake was necessary so that the research in the field could progress in giant steps. It is, indeed, at the end of the Second World War that the two great world powers, the USSR and the USA, play a decisive game to give a guideline to the world, and that passes by the conquest of space. Until now, researchers were mainly interested in our planet. Many important scientific studies have been carried out in the bowels of the Earth or in the deep sea. Many explorations have also been carried out to discover the last unexplored parts of the Earth. At the same time, some technological feats in the field of space have been carried out, notably the invention of the telescope by Newton in 1672, or the launch of the first ballistic missile in 1942 by von Braun. However, the conquest of space was not yet a central point of research. In the 1950s, however, the Cold War, led by the two great powers of the planet, changed the situation. To return to the context of the time, it's necessary to know that in the aftermath of the Second World War, the USA and the USSR did not agree on the cutting of Europe. From then on, tensions were felt between the two parties. Although the desire to explore places outside our planet guided the scientists, the two governments also had another goal in mind: to prove to the rest of the world that only one of them was the best. Nobody had yet gone into space at that time. To succeed in such a feat was to succeed in proving to the eyes of the world its military, geopolitical, strategic, and technological power, and thus to establish a certain authority. To do this, men had to defy the laws of physics. October 4th, 1957 marked a turning point for humanity. It is the USSR which wins the first round. On that day, it managed to put into orbit the first artificial satellite, the famous Sputnik. This satellite was put in orbit around the Earth thanks to the launch of the R-7 rocket at 7:28 p.m. from the military base Tyuratam. This rocket is a small engineering marvel designed by Sergei Korolev. The mission of Sputnik was very precise. It was to provide the world with data on the propagation of waves in the atmosphere. researchers hope to discover more about the density of the atmosphere, but also about the upper atmosphere and its precise shape. Unfortunately for Sputnik, it ends its days in a dramatic way. After 22 days in space, its battery is exhausted. It must thus return to Earth. On January 4, 1958, it will finish its race in the atmosphere, disintegrated. It remains nevertheless an important event in the history of the conquest of space, and the USSR can be pleased to have sent the first human machine to travel such a distance in the universe. Far from being satisfied with this first success, the USSR follows with the second world exploit the same year. On November 3, 1957, one of the world's greatest powers launched Sputnik 2. This time, it was the opportunity to send the first living being into space. A dog named Laika would be part of the trip. The USSR then sets the bar a little higher. It shows clearly they desire to cross a new step, that to send a living being in the universe. Laika enters then in the history of our civilization and becomes the first living being to leave the ground of the Earth to cross the atmosphere and enter space. Laika was a small 3-year-old dog who wandered in the streets of Moscow. Despite her humble origins and her sad story, she will know an incredible destiny. Albert I, a primate, was sent into weightlessness long before Laika in 1949, but his journey led him to 63 kilometers of altitude, that is to say, almost 40 miles high. Laika was the first living being to reach a suborbital altitude, 1,600 kilometers, almost 1,000 miles. Unfortunately, after a few hours, the small dog, which is a cross between a husky and a terrier, will not survive. In spite of the announcements made by the Soviets who advocated the contrary, the dog finally died after only a few hours. The USA has to catch up, but they have a hard time competing for the moment. Although in 1958 they launched the satellite Explorer 1, the USSR is not at its first try. However, Explorer 1 is at the origin of the discovery of the Van Allen belt. This zone contains a high density of energetic particles and plays a major role for the Earth. It originates at the two magnetic poles of the Earth and allows us to block the solar wind radiation. In order to better organize and structure their research, the USA decided the same year to create the National Aeronautics and Space Administration, NASA, in October 1958. The USSR again takes the lead. This time, the passengers are more numerous on board. 2 dogs, 1 rabbit, 40 mice, 2 rats, fruit flies, but also plants will conduct a revolution around the Earth. This time, the success is there. The passengers return to Earth with their hearts beating. For the record, one of the female dogs, Strelka, will even give birth to puppies a few months later. One of them will be gifted to the Kennedys. Nikita Khrushchev, the main leader of the USSR and the Communist Party of the Soviet Union from 1953 to 1964, offered this little puppy to the daughter of President John Fitzgerald Kennedy. A simple gift without ulterior motive or a small provocation? We will never know. The USSR continues its quest and makes history once again. It strikes again with an exceptional exploit to put the first man in space. It will be Yuri Gagarin who will have this honor on April 12, 1961. He made a flight of about 2 hours around the Earth in orbit. Imagine what Yuri could feel. Before him, no one had ever seen what he could admire with his own eyes. To be the pioneer of such an event must be absolutely incredible. The emotions of Yuri Gagarin are indescribable. Valentina Tereshkova, only 26 years old. She was the first woman, but also the youngest cosmonaut to be sent into space. Yes, the USSR has definitely not finished surprising the world. It multiplies the technological feats and the exploits. But the Americans don't want to tuck their tail in defeat. They feel that the gap is widening and try to react. They then create the Apollo program under the presidency of Kennedy. The president then clearly expressed his goal to send the first man to the moon. A few years later, the USA succeeded in flying a whole crew in orbit around the moon during the Apollo 8 mission. However, the contract was not yet completely fulfilled. As you can imagine, a mission of this magnitude requires a lot of preparation. The goal was for humanity to take its first steps on the moon, so the astronauts had to be equipped with many qualities. Their skills in science and physics are paramount, but their physical capacity is just as essential. The trainings are intensive. The three teammates will show the fruits of their labor in front of the press. Neil Armstrong will be the commander of this mission, alongside Buzz Aldrin and Michael Collins. The crew of the Apollo 11 mission enters history aboard Saturn V. It's the name of the launcher that will propel them towards the moon. It will take off from the Kennedy Space Station in Florida on July 16, 1969 at 1:32 p.m. But President Kennedy's challenge is not yet complete. It will, however, be done on July 20th, day of the lunar module landing. Armstrong the first, followed closely by Aldrin, will have the honor of being the first men to step on the moon. Everything didn't go as initially envisioned, but the capacity of adaptation of the crew allowed them to carry out the mission. The zone of the landing was very precise. It had been largely studied upstream in order to allow the crew to safely land on a smooth zone. The phase of descent towards the moon was initiated on July 19th, but when the astronauts approached the moon, their speed was a little too fast. It then missed the zone by 5 kilometers, that is to say 3 miles. At this place, rocks were present. Thus, there was no possibility to put the lander down. However, Armstrong takes things into his own hands and pilots the module manually for 500 meters, that is to say 1,640 feet. Finally, it's on July 20th at 2:34 a.m. that the crew finally lands on the moon. Imagine the feat. The population was divided at the time. Some thought it was impossible. Others had high hopes for the mission. When the module finally lands, the joy is immense. But it is the next day that the history of the space conquest will really end. At 3:56 a.m., Armstrong became the first man to walk on the moon. 600 million viewers followed this historic event live. NASA had developed a camera especially for this mission to allow the whole world to follow the crew. Armstrong describes his first impressions. The moon is covered with a thin layer of dust. 22 minutes after him, it is his teammate, Aldrin, who will in turn step on the natural satellite of our planet, the moon. The statement made by Neil Armstrong will remain forever engraved in our memories, even for future generations. One small step for man, one giant leap for mankind. The return to Earth for these men who have become great names in history will take place on July 24th. From then on, they will come back with splendid images. the Apollo program is indeed the pinnacle of space exploration. Many decades later, nearly 15 countries are working together to take advantage of each other's knowledge, abilities, and strengths within the same structure, the ISS. The International Space Station was born in 1998 from the merger of three major projects: the American Freedom Station, the Soviet Mir 2 station, and the European Columbus Laboratory. But the investigation, their research, and the conception are much older. In May 1982, NASA set up a working group specifically dedicated to the design of the ISS. It took $115 billion, more than 10 years, and nearly 30 space missions to assemble all the parts of the station. It must be said that the ISS is almost the size of a soccer field. It is 110 meters long, 74 meters wide, and about 30 meters high. That is, 360 feet long, 240 feet wide, and about 100 feet high. Inside, although the volume is much larger, it houses an interior living area of nearly 400 meters cubed, or 14,000 cubic feet, and it has approximately 25 square meters of solar panels, or 27,000 square feet. This gigantic space station exceeds 400 tons. It is so bright and imposing that you can see it with the naked eye from Earth on the clearest nights. The ISS is a giant laboratory floating in space. It allows astronauts to carry out multiple experiments in various fields in the absence of gravity and a hostile environment, space. It's located at an altitude of 400 kilometers, or about 250 miles, and orbits the Earth. In only 90 minutes, it goes around our planet. It moves at a speed of about 28,000 kilometers per hour, or 17,000 miles per hour. This laboratory in orbit is under the dome of 5 space agencies: NASA for the United States, Roscosmos for Russia, ESA for Europe, JAXA for Japan, and finally the CSA for Canada. In this laboratory, we try to understand the behavior of materials in microgravity, but also to observe and collect valuable data on the reactions of the human body, animals, and plants in space. If the ISS is more of a research laboratory, other man-made tools are specifically dedicated to the discovery and analysis of space. The development of the Hubble telescope began in the 1960s. The National Academy of Sciences of the United States proposed the construction of a large space telescope. Due to a lack of funding, the project slowed down. However, in 1977, it obtained the favors of Congress and the necessary financing. 13 meters or 43 feet long, 4 meters or 13 feet wide with the panels deployed, 2 meters or 7 feet in diameter, the Hubble weighs nearly 11 tons. This giant telescope is incredibly accurate, 10 nanometers to be exact. Of course, the construction of such a machine takes many years. In October 1986, less than 10 years later, the launch is planned, but an accident will upset the plans of this new space exploit. The Space Shuttle Challenger exploded after its launch in January of the same year. The space program concerning the Hubble project is postponed. The flights will resume only 2 years later in 1988. In 1990, all the lights are green. We think of the launch of Hubble during the year. On April 24th, the Space Shuttle Discovery takes Hubble with it to place it in orbit. On April 25th, 1990, the Space Shuttle Discovery will place the famous telescope in orbit at 590 kilometers or 366 miles in altitude, everything goes as planned. Well, almost. The first images of the telescope are really not good. A few weeks after its commissioning, Hubble is not as efficient as expected. The mirror is at fault. It is distorted, 22 micrometers of error. It seems insignificant, and yet the pictures are blurred. The press gets hold of the subject and denounces the Hubble fiasco. The problem is that the mirror is the main part of the telescope. Even if everything has been planned for repairs in space, it cannot be changed. The researchers, supported by the precious help of engineers, will develop a correction. In 1993, a space mission allows us to correct this error. The funniest part of the story is that to correct the error, the astronauts had to unsettle the instruments to distort them in order to take into account the manufacturing defect of the mirror and to cancel the visual defect. After 30 years of good and loyal service, 6 shuttle missions, and no less than 120 gigabytes of images transmitted each day to the ground, Hubble has helped to highlight many phenomena in the universe. 1994 marks the discovery of the construction of galaxies. It allows us to visualize nearby galaxies and other very distant and irregular ones. We know today, thanks to its images, that galaxies almost all contain black holes, that the universe is also made of dark matter, matter that does not emit light, that exoplanets exist, or that the universe is expanding and growing faster and faster. Hubble has played an essential role in the discovery and understanding of the universe. The images it has been able to transmit to us have allowed us to collect precious data. The James Webb Telescope has been in the news a lot in the last few months, and for good reason. Since its launch on December 25, 2021, it's the most powerful telescope ever sent into space. It is a priceless Christmas gift for astronauts and scientists, but also for all star lovers and humanity as a whole. Its mission is to go back in time to the origins of the Big Bang, and thus of the universe. Scientists would also like to observe the first stars and the first galaxies in order to find some answers about the loss of diversity of the latter. To carry out its mission, a whole armada of technology and engineering treasures were required. Its 6.5 meter or 21 foot mirror is composed of 18 hexagonal mirrors to allow folding and facilitate its launch by the Ariane 5. It's announced as 100 times more powerful and efficient than Hubble. The least we can say is that the bet is kept. The big plus of this extraordinary telescope is its infrared vision. It can observe wavelengths between 1/2 and 30 micrometers. Its high sensitivity also allows it to scrutinize cooler objects, such as dust or gas. In July 2022, the first Webb images were revealed to the general public. The images are of an unprecedented beauty. Nebula can be seen like never before, and the images allow us to analyze the atmosphere of an exoplanet or galaxies in collision. Here, for example, is the famous shot of the Carina Nebula, located at about 7,600 light-years from us. This nebula is a real nursery of stars. Nearly 20,000 people worked on the realization of James Webb. After only a few months, the joint effort was worth it. Posted more than 1.5 million kilometers from Earth, almost 1 million miles, it's designed to work on a mission for at least 20 years. The transmitted images promise some nice surprises. Researchers hope to finally understand the origin and the different mechanisms that govern the universe. But for the moment, this mission is ours. It's time to conquer space and discover its wonderful history. Astronomers believe that the universe was born in the Big Bang. Before that, in a bubble thousands of times smaller than the fingernail on your little finger, an incredibly hot and extremely dense bubble stood the beginnings of the universe. We hope that James Webb can help us understand what caused this bubble to explode. What we know at the moment, using the standard model, is that this tiny bubble exploded. This is the Big Bang. This explosion led to chain reactions and the creation of the universe, but also of time passing, matter, space, and motion. However, it was not as big as it is today. Like a newborn baby, it grows with the passing of time. At first, it becomes as big as a galaxy, a few million billion kilometers or miles all the same. But this is tiny compared to the size it would have today. It hasn't stopped growing, and as you watch this video, it's still expanding a bit more at an amazing rate. But let's go back to its first few seconds of life. While it has only just hatched and is expanding, growing, and cooling, from then on, the energy produced by this phenomenon is transformed into particles of matter and antimatter. Before going any further, I think it's time for us to take a short break in the middle of this incredible landscape to talk about matter and antimatter. Now, let's go back to the birth of the universe and the creation of matter and antimatter. Both are of completely opposite particles and therefore partly destroy each other. In spite of everything, a small quantity of matter survived, if one can say things thus, with this war of particles. This is what allowed, only 1 second after this mega explosion, the formation of stable particles, neutrons and protons. The role of these two particles is to maintain the cohesion of a nucleus. Together, they exert the nuclear force, as opposed to the electromagnetic force. They are finally the essential components, the foundations of a nucleus. During these precious minutes, the temperature drops sharply to below 1 billion degrees. I can imagine your reaction. This temperature is absolutely unthinkable. Nature, this great whole, is as mysterious and enigmatic as it is fantastic. It has given birth to thousands of incredible phenomena. The creation of the universe is wonderful, almost magical. In spite of this heat, which is intense to say the least, it's cold enough to encourage and trigger another phenomenon, that of the formation of hydrogen and helium nuclei. At this stage and at this temperature, protons and neutrons will be able to reunite and in turn give birth to new molecules. These two components form what we call subatomic particles. The universe has aged well. 300,000 years have passed since its birth, and yet it's still very young. It took almost 300,000 years for new reactions to take shape. This is huge, and at the same time, it's nothing. It represents only 1,000th of a second on the scale of the universe. It's probably at this moment that we realize that we represent a very small part of the history of the universe. On our human scale, we live for the luckiest of us only a century at most. The history of mankind began only 7 million years ago. If we rely on the discovery of the oldest fossil of the genus Homo found in Chad in 2001, it is the skull of Toumai. These figures are already far enough away to be impressive. The tragic end of many dinosaurs dates back to more than 66 million years ago. It's increasingly difficult for us to visualize such a period, to make concrete such a significant duration, and especially so far from us. So, what about the creation of the universe? How can we imagine that so many years ago, the creation of such an incredible phenomenon could later give life to our own human civilization? Let's go back to the very beginning of this incredible story, where a new step will allow a new turn to the universe. Remember, the temperature used to reach almost 1 billion degrees. This astronomical temperature allowed the birth of protons and neutrons. Over the millennia, the temperature continues to drop little by little to reach 300,000 years later, 3,000 degrees Celsius or 5,432 degrees Fahrenheit. This is still incredibly hot, but this temperature allows a phenomenon that will change the course of things for billions of years. The atomic nuclei will finally have the possibility to capture electrons, our famous neutrons and protons, to form the first atoms of the universe. These atoms then form clouds of hydrogen and helium. These clouds will become the beginnings of the most beautiful constellations that you admire every night with the same emotion. Of these past 300,000 years, we can observe nothing today. Scientists are still trying to unravel the many mysteries that revolve around the birth of the universe and its growth, particularly through their knowledge of atomic particles and by relying on technology and complex calculations made possible by computers. Nevertheless, we can perceive traces of the Big Bang thanks to the telescopes and the balloon probes that we've sent into space. The light emitted by this mega explosion is still infinitely perceptible in the form of a mixture of very diffuse gas. We can also notice then that the gas clouds are subtly denser. After several million years, the dense areas have become matter. They do not resemble the first cloud of hydrogen anymore. These clouds that allowed the matter could also, many years later, give birth to the first stars. A galaxy is a cosmic structure formed by stars and their possible planets, gas, interstellar dust, perhaps mainly dark matter, and often containing a supermassive black hole in its center. This is how we could define a galaxy, but on this journey, I would like to take you further. I'd like to make you discover a unique phenomenon, the birth of a galaxy. 100 million years after the Big Bang, the gas is heated and dense enough to give birth to the first stars. Although the birth of a star requires time, during the period closest to the Big Bang, the stars were born 10 times faster than today. While they were born faster, they were also much closer together than they are today. During this period, collisions between galaxies were not rare, quite the contrary. They regularly collided and merged together to form a larger galaxy. This is in fact what happened to our own galaxy, the Milky Way. There was a time when it was thought that current galaxies were the result of collisions between smaller galaxies. Since Edwin Hubble in 1920, we know that the secret of the birth of galaxies is quite different. So, how could gas and stars in the middle of the void have created galaxies? The mystery remains unsolved, and several hypotheses have been put forward by the great names in astrology and physics. However, we do know some key facts about the birth of galaxies. Their history begins about 300,000 years after the Big Bang. It's precisely at this time that the first atoms are born. The drop in temperature and density favors the decoupling of matter and radiation. At this stage, photons stop interacting with matter. Then, the question remains open. We know that the gravitational force is probably at the origin of the formation phenomenon. What we do not know yet is how and why. For the moment, two theories clash. The top-down theory, that is to say, from the biggest to the smallest, and the bottom-up theory, in other words, from the smallest to the biggest. The first one puts forward the idea that it is particles of matter that have formed giant clouds, then superclusters. The latter, by their density and the force of gravity, would have collapsed on themselves and would then have given birth to galaxies. For the second theory, we finally start from a small concentration of matter that would have given birth to larger clouds of matter, then forming stars and proto-galaxies. In other words, the beginnings of a galaxy. Under the effect of gravity once again, these proto-galaxies attract and merge to form larger galaxies. We do not know yet which of these theories is the right one, but what is certain is that the phenomenon is incredible. The Carina Nebula, the star nursery, is absolutely incredible. Look at these shades of color, these shapes, and these lights. The universe truly has something magical and extraordinary. A star is a celestial body, but unlike a planet or other astronomical object, it radiates its own light by nuclear fusion reaction. The mass determines the temperature and luminosity of the star. The most known to us humans is undoubtedly the Sun. It's our star, the one of our solar system. Its diameter is colossal, nearly 1 million kilometers, or 620,000 miles. To give you an order of magnitude, it's nearly 109 times the size of the Earth. But if you look around you, you'll see that there are billions of other stars, but also that the Sun is not the largest. There are different types of stars. Astronomers have therefore established different classes of stars according to their temperature and brightness. This classification is not fixed in time. A star goes through different temporary phases during its existence and can change color and category several times during its life. The different types of stars are brown dwarfs, red dwarfs, yellow dwarfs, which includes the Sun, red giants, blue giants, red supergiants, white dwarfs, neutron stars, and black holes. When a massive star reaches the end of its life, it causes an impressive explosion called a supernova. It then releases star material, interstellar dust, and creates a very intense magnetic field. The Sun is a yellow dwarf star. It is far from being the largest in our galaxy. For the most impressive, we speak of giant stars and massive stars. VY Canis Majoris has long held the record of the largest star. Located at more than 5,000 light-years from us, it's located in the constellation of the Big Dog. It's about 1,500 times bigger than our Sun, or 2 billion kilometers in diameter, almost 1.2 billion miles. UY Scuti is located in the constellation of the Shield of Sobieski. It measures 1,700 times the Sun. Finally, Arrakis also called the Garnet Star, is located in the constellation of Cepheus. It's located about 5,200 light years from our planet. Despite this distance, it can be seen without instruments. This is what makes it famous and popular with astronomy enthusiasts. As you can see, our sun looks quite small next to these behemoths. But we should not be disappointed. On the contrary, their impressive size symbolizes their decline. Such a huge star is finally a star that is dying. Our sun still has many years ahead of it. This is rather reassuring news, don't you think? Within these galaxies, thousands of planets orbit alongside many stars. Both the planet and the star are celestial bodies, but unlike the star, the planet does not produce its own light. Moreover, it orbits a star. This is the case for the 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The planets are closely related to the stars. In our own galaxy, it's estimated that there are between 100 and 300 billion stars. Knowing that the majority of them probably have a planet orbiting it, we can therefore consider that there are also at least 100 billion planets in the Milky Way alone. If a star lives long enough, the formation of planets seems to be the logical consequence of their evolution. But this data is only estimates. It's very difficult to map most of the planets. Today, only a little over 4,000 planets have been confirmed by astrologers. The first one was discovered in 1990. We speak then of exoplanets, that is to say, planets that are located outside our solar system. Knowing that our universe can house more than 2,000 billion galaxies, and that each of them has billions of stars and therefore planets, we are still far from accounting for them all. Researchers are trying to clarify our understanding of the universe, but the numbers are so large that it's difficult for our human brain to visualize concretely such an order of magnitude. Realize that if our universe, as the majority of astrophysicists think, has 1 quintillion more than 1 trillion stars, that is 1 in 27 zeros. There would be at least as many planets, certainly hundreds of trillions. Like our solar system, some stars may have several planets around them. Since then, technology and new observation instruments have allowed many discoveries. A planet comparable to Earth, Kepler 1649c, lies in the Kepler 1649 system, 300 light-years from Earth, and the constellation Cygnus was discovered in 2020. Although we still expect a lot from James Webb about the origin of the universe and the extent of stars and planets, there are some areas, as you will see, where our knowledge is very limited. Dark matter is a very mysterious component. It would seem to be made up of elementary particles, such was the case shortly after the Big Bang, i.e. protons, neutrons, and electrons. Without electric charge, these particles do not interact with normal matter, but they still have a gravitational attraction. This enigmatic matter is found in galaxies and clusters, but also in the fossil radiation that follows the birth of galaxies. Is it solid? Is it present in another form? We don't know for the moment. Some astrologers think that we're on the wrong track and that, perhaps, our perception of the law of gravity on the scale of the universe is not concordant. We still have a lot to learn on the subject. The word alone makes the most down-to-earth people shudder. How can antimatter exist? Matter is everything that we perceive, touch, and feel. In the collective imagination, the negation of it is simply unimaginable and beyond comprehension. However, antimatter is not as mysterious as that. To understand antimatter, let's go back to matter for a moment. Matter is made up of atoms and molecules which are themselves made up of electrons and atomic nuclei. The latter are made up of protons and neutrons, also called nucleons. We know that these particles are charged. The electron, for example, is conventionally described as negatively charged. However, we also know that these particles can interact between them. That is to say that electric charges of the same sign repel, while opposite charges attract. Since the theoretical invention of Paul Dirac in 1928, it's believed that each of these particles is associated with a particle quite similar, but with an opposite electric charge. In 1932, Anderson confirmed Dirac's position. A particle with the same mass as the electron, but with an opposite charge, is discovered. It is a particle of antimatter. There are different types of antiparticles: antiprotons, antielectrons, and antineutrons, etc. Antimatter is in the news so much probably because it has an amazing property. When a particle of matter meets a particle of antimatter that corresponds to it, it produces a reaction and leads to the annihilation of both. They disappear and form new particles. Antimatter is therefore very unstable. If the phenomenon can frighten, it should not be demonized. This annihilation causes a great instability on the matter, but it can be of precious help. We're thinking, for example, of using antiprotons to treat cancerous tumors. The universe is immensely large, but also immensely complex. Even the greatest astrologers, astrophysicists, mathematicians, and other researchers cannot solve all the equations that revolve around the universe. This is undoubtedly why the phenomenon fascinates men so much. It is at the same time always there, present and real, and at the same time it is completely inaccessible, disproportionate, even unreasonable. The celestial bodies that dance in space before our eyes when the night is perfectly clear without any light pollution is as beautiful as a poem. The colors, the shapes, the movements, the glows are absolutely extraordinary. They have always amazed children and adults alike. The scientists thus wished to make accessible the knowledge of the universe to satisfy the curiosity of all, but sometimes, to explain things, it's necessary to simplify them. However, to simplify them too much, one moves away from the truth. When we admire pretty pictures in magazines and documentaries, we represent the planets well round and of different colors. We sometimes notice a subtle difference in the representation of the sizes of the planets and the sun, but this is often far from the truth. The reason is simple. It's very difficult to include the sun and the planets in the same image. If you want to preserve the proportions of the sun, then you will not be able to see the planets because they would be too small. On the other hand, if you want to preserve the proportions of the planets to admire the rings of Saturn, the shades of color of the Earth, or the dozens of natural satellites of Jupiter, then you will never be able to include the sun in this same representation. If the sun was represented by a soccer ball, then the Earth would not be the size of a single grape. Imagine that if Mercury was represented by a mini ball, about 8 millimeters, the sun would have to be 8.5 meters, or 5 feet, to respect the proportions in space. Mercury should be 68 meters from the sun, or 223 feet from the sun, Venus and the Earth are of similar sizes. They would be represented by a normal ball, around 14 and 16 millimeters. Venus would be 120 meters, or 395 feet from the Sun, and the Earth 66 meters further, or 216 feet further. All this, it does not fit on a conventional A4 sheet. The size of our solar system would be based on a pattern of more than 11 kilometers, almost 7 miles. The distances between the planets and the satellites are not very realistic. When we draw the Earth and the Moon, for example, they're usually very close to each other. However, the Moon is located more than 380,000 kilometers from the Earth, that is to say, 236,000 miles. The shepherd star is a very popular expression. It dates back several centuries and comes from the herdsmen who lived to the rhythm of the seasons, days and nights to guide their animals in the pastures. This star is the first to show its beautiful light in the morning. When it appeared, the shepherds knew that it was time to return the sheep to the sheepfold. In the morning, she was also one of the last to leave the sky before the sun came to cover the earth with its rays full of light and warmth. The shepherds knew then that they could take the sheep out to the pasture. But the shepherd star is not a star. The shepherd star is actually a planet. It is Venus. Yes, it's much closer than you thought to Earth. It is only 42 million kilometers from us, or 26 million miles. To give you an order of magnitude, the Sun is more than 150 million kilometers from our planet, almost 93 million miles. It may sound crazy, but in space, there's no noise. You could imagine the movements of all these celestial bodies without hearing a single sound. There's a very simple reason for this. Sound is made of vibrations. These are the sound waves that we perceive. They spread a bit like a wave through a given medium. They do not deform the medium in which they propagate. We can say that the wave compresses, then decompresses the medium. To better understand, it's like a small circle in the water that propagates. It is finally the compression that moves, and not the water or air molecules. The denser the medium, the faster the propagation. The waves move much faster in water than in air. Yes, as surprising as it may seem, sound travels at 1,525 meters per second in water, or 5,000 feet per second, and only 334 meters per second in air, or 1,095 feet per second. But in space, everything is different. The void is endless. There is no medium in which to propagate the waves. The only exception is on planets that have an atmosphere, but everywhere else, there are no molecules to carry the waves. It is thus the inner sidereal silence which reigns as master in the universe. As you have seen, the universe is incredibly complex. It abounds in phenomena more extraordinary than the others. A large part of them is still a mystery to man. Despite thousands of years of civilization spent observing the stars and trying to understand the universe, many of our questions still remain unanswered.